Basic electricity. Electricity consists of three major aspects: voltage, current, and resistance. Voltage is what makes an electric charge move. Current is how fast or how slow that charge moves. And resistance is what impedes the flow of current. Current flows more easily through conductors, such as wires, and has a more difficult time flowing through materials known as insulators, such as the coating around those wires. Having a basic understanding of how electricity works within appliances will give you great insight into how they function and how to approach an investigation when things might not be working perfectly. Grounding. Grounding is a way of connecting electrical equipment and systems to the earth by a conductor. This is done for safety reasons because it reduces the risk of electric shock from a current leaking into uninsulated metal parts of the electrical device. Most electrical systems have fuses or circuit breakers to protect against short circuits, but as humans, we were not built with the same safety measures. This is why we need to be extra careful when working on these systems. You may notice that rods are placed on top of some houses and buildings as a form of grounding to protect against lightning. Transformers are devices which reduce or increase AC input. Outside the home, you can see transformers on electrical poles. For example, a typical residential installation reduces the voltage from thousands of volts to 240 volts. Inside gas appliances, transformers are a lot smaller. Step-down transformers reduce the higher voltage primary input from 120 volts into 24 volts on the secondary lower voltage side of the transformer. At the appliance. Inside an appliance, there are two kinds of circuits. The primary circuit, which supplies a higher voltage to the components that require it, and a secondary circuit, which provides a lower voltage to the necessary components. In many cases, the only low-voltage components you need to be aware of are the thermostat, limit switches, and the control valve. Electrical circuits. An electrical circuit is a closed loop, allowing the electrical current to flow through it. Circuits are nothing more than a voltage source, one or more connected loads, and a controlling device. Circuits can get much more complex, consisting of multiple components, all connected in specific ways so that each component can do its job. As complex as they can be, all circuits must obey the basic principle of a closed loop. Laid out inside an appliance, these circuits look like anything but the simple circuits they really are. AC and DC current. Alternating current, or AC, periodically reverses the direction the current is moving in. One example of this would be residential electrical current, like that which is used in a forced air furnace. Alternating current reverses its direction every 1/120th of a second. Direct current, or DC, travels in the same direction all the time. This is the current you would get from components such as batteries, thermocouples, and pilot generators. Diagrams. Appliance wiring diagrams show the connection points of each wire used. These can be schematic or ladder diagrams. Schematic diagrams show how all working components are connected together, which includes the connected wiring. This can be helpful when troubleshooting problems. Ladder diagrams show the components and their location on the primary or secondary side of the transformer. Most loads are wired in parallel across their voltage source because a load in parallel is unaffected by other loads unless those loads short out. Looking at individual circuits in parallel is like looking at any simple circuit. Most control circuits, on the other hand, are connected in series with the components they are controlling. A switch that is normally open will keep any component in series with it off until the switch is closed. All switches connected in series must be closed for a connected load to operate. Switches and controls are important circuit elements to understand when looking at a wiring diagram. Diagrams are visual floor plans for the electrical parts of a system. Taking the right action with an electrical circuit is 95% knowing what to do and 5% actually doing it. The wiring diagrams make the first part much easier to do. Basic system check. Electrical devices do fail, but many problems are caused by something other than a component failure. The 3 C's for a basic system check are connections, continuity, and controls. When checking connections, you must determine that all the components are wired together correctly. As the number of possible connections goes up, the more likely it is that there will be a wrong one. Voltage continuity asks whether all wires and components are good with no breaks and that all terminal connections are solid. It also asks if all switch contacts are conducting as they should. If a multimeter is used to check continuity across a pair of contacts, the circuit must be operating. The meter should show voltage when the component is open and should not show applied voltage when the component is closed. All other connected controls must be known. If the contacts from the other controls are connected in parallel across the control being tested, the voltage test cannot be used unless the status of the other contacts is known. A controls check is the final area of circuit troubleshooting. A significant percentage of electrical problems can be traced to controls that are not properly set to work together with other circuit components. Correct settings can either be calibration settings that must be made or mechanical switches that must be set. Switches must all be set correctly for the control and its operating components to work properly. Safety. Electricity does not change its actions. It is always consistent. That is why it is important for you to be consistent with what you do for the safety of yourself and for others. One of the biggest myths that surrounds electricity is that it takes a lot of voltage to injure or kill. Nothing could be more wrong. 10,000 volts will not necessarily kill, but less than 1/2 of 1 ampere, which is electrical current, could easily cause instant death. When working near electrical circuits, make sure to follow these rules. Know where line voltage and ground are located. Never be in a position where your body can be across this line when power is on. Whenever possible, work on electrical circuits with the power turned off. Be especially careful when working while heavily perspiring. Moisture on the skin will dramatically lower the resistance of the skin and clothing. The lower the resistance, the higher the current flow should an accident happen. Never operate or service electrical equipment while standing in a wet area. The better the ground connection, the greater the current flow. Make sure safety ground wires are always connected. In the field, you take hundreds of actions, so it's crucial to always keep safety in mind. Electricity is a very powerful friend, there to serve us. Treat it with respect.